Everybody, good afternoon, and welcome to session 3 of day 2 of the 2021 United Nations Big Data Forum. It's been a very exciting program so far, and it's about to get all much better as well as we are joined by Mr. Atri Sharma, a distinguished engineer at Securonics and a member and fellow at the Apache Software Foundation. He will today lead a presentation entitled Transforming the World, One Byte at a Time. Mr. Sharma is, as I've noted, a distinguished engineer at Securonics and an Apache Software Foundation member. He's a database and search engines expert, having worked on PostgreSQL, ordered set aggregates and grouping sets, Greenplum, distributed LOB and query planner, Microsoft Cosmos DB, and Microsoft Cosmos DB. He is an Apache licensed Apache SOLR PMC member and was a core member of the group that rewrote the product search engine at Amazon using Apache Lucene. He is the author of Practical Apache Lucene 8, published by A. Springer. I'm sorry if I butchered some of these technical terms. As you can see, I'm somebody who is still struggling to fully control Microsoft Outlook, let alone anything more complex than that when it comes to big data. But it is still a great pleasure and a great privilege to welcome Mr. Sharma to the forum and to give him an opportunity for this presentation. For our participants, I would like to invite you to share any questions that you have in the Q&A box at the bottom of the screen. And we can then ask these questions to Mr. Sharma after he finishes his presentation. But now, without much further ado, I would like to hand the floor over to Mr. Sharma. Welcome again to the Trinidad and Tobago Big Data Forum. We're very pleased to have you here, and we're looking forward to your participation. Thank you. Mr. Sharma, you're muted.
Yeah, am I audible now? I'm not able to speak for some reason. I don't know what's happening. 1 second. Yeah, am I audible or is the audio clear?
Yes, the audio is very clear. We can hear you very well.
All right. Thank you so much for introducing me, and thank you for having me in the forum. It's a real pleasure to be here. And I could not have done a more kind introduction about myself. So I'll not spare any more time on that. So thank you for that. So we'll be talking about the role of big data technologies in the way we view the world. This presentation will talk a bit about what really does big data mean. We've all heard this terminology, but we will be quantifying what big data really means today in terms of numbers and what it meant maybe a decade or two earlier, so that we can really see this entire phenomenon of information explosion. I'll just take this, then we'll go up, a bit into Apache Software Foundation and why is it vital to the way technology is progressing. And it is not just commercial vendors, it's also the way, I think Apache Software Foundation has percolated in the nooks and crannies of things like, automated farming, and you'll see as the presentation progresses. And then we have a load of case studies where we'll be looking at actual real world scenarios where big data software or open source big data software, specifically around ASF, has actually made a quantifiable impact in the lives of people. And then, we'll conclude the presentation with talking about what's coming next, how's the world progressing, how's the technology horizon progressing, and what we can expect to see in the next couple of years. So, this will be our today's agenda. I just like to do this at every presentation. Each of my presentations dedicated to my mother, who has always been my guiding light. And fun fact, she also taught me my first programming language when I was 7. So, to give a bit of a background, when we measure data, these are the standard measurement units that we use, right? You always hear, I have a laptop of 16 GB RAM, right? So that's these many bytes. And to give you context, my father wrote code on a machine that had a physical disk, right? Basically what we call hard disk today. It had a physical memory of, I think 512 kilobytes. This was in early 90s. So at that point, I think many eminent computer scientists made the statement that that was going to be enough for any reasonable storage. And 512 KB is, we don't even talk about that these days. So these are the standard units in which we really measure data. It's like 1,000 bytes, then there's 1,000 to the power 2, 3, 4, 5 exabytes. Now, back in the 1980s or 70s, nobody really talked about anything beyond a gigabyte, right? A gigabyte was something that IBM Almaden was dealing with, right? You would see machine filled, room filled of large storage devices, tapes, which were dealing with, let's say, a few megabytes of data. And that was huge. That was mammoth scale back in those days. And beyond a gigabyte, people never even discussed. Anything of that was purely theoretical, right? Only big research labs and big organizations really had data, anything above that scale. But now, if you look at the history of how big data has really progressed, right? These are some of the events that have shaped the face of big data, right? So 1997, Michael Less published this theory, this paper called How Much Information There's a World. And he said that there might be a few thousand petabytes of information across the globe, right? This is like everything quantified. This was what his prediction was. And he said that by year 2000, we'll have enough disk and RAID that will basically reach a few petabytes. Then 1998, there was a study which said that internet traffic is growing at 100%, right? When voice traffic was actually growing at only about 45%, internet traffic was growing at 100% year on year, right? And that really was the biggest indication of what we call information explosion, right? Because if you look at the data today, all of it comes from internet, right? And the more connected devices we have, the more we are connected to the internet, because the internet is no longer about www.google.com. It's a web, it's a meta web now. So that really was the first indication that this is where the actual data stream is going to come from. Then Doug Laney, published a seminal paper called the 3 data management, data volume, velocity, and variety, which is something which is actively used by data analysts even today to understand and quantify the quality of their incoming data. Then, in December 2009, again, we have taken a large leap, but 2009 paper is very interesting because it said that American consumers in 2008 consume information for 1.3 trillion hours for about 12 hours per day, right? The consumption total 3.6 zettabytes. Now, this is the first time you actually hear the term zettabyte in a more conventional way. Before that, zettabyte was just a number in a computer science textbook, right? Now it's a real quantified piece of information that is associated with an American consumer, right? So this was the first time when people really felt the depth of what big data is all about. And then, the hindsight there was that big data is all about humanification, right? As humans, we interact and generate so much data that consuming that data, processing that data itself is a challenge. And that is the crux of all the big data technologies that we talk about today. So, as I said, in 1.5 exabytes of data was the total, the measured, there was a survey and it said that 1.5 exabyte data is everything that we have, including internet, voice, tapes, long-term storage, everything. If we quantified, it's around 1.5 exabytes of data, and 1 gigabyte was considered pretty significant, right? It was like, okay, if a company has 1 gigabyte of data, it's considered to be, a large factor and all something that you need to think about in terms of cost. Now, today, we don't even think about 1 GB of cost, right? This was an interesting number. If you remember the paper that we talked about earlier, the prediction was that we have 100% year-on-year growth, right? And by 2000 or 2001, we'll reach a few petabytes of data. But 2006, we had 160 exabytes of data, right? 1,000% more. So what needs to be realized here is that the growth of data is not linear and it cannot be predicted. Year on year, we have more ways of being connected. We have more devices that are around us. And even my new refrigerator is smart, right? So it probably is pumping some data in some remote cloud and adding to this overall data mass. So this is in reality the definition of big data. Now, 2006, 106 exabytes, and we'll talk about what it looks like today. But this is indicative of the growth pattern that we have seen over the years. Now we enter what we call a Zettabyte era. Like I said, this is what a zettabyte looks like, these many bytes, right? And Cisco in 2016 estimated that we already passed 1 zettabyte in total internet traffic, right? And when I say internet traffic, that's basically what we upload and what we share, right? It's basically like what you upload on Facebook or any files that you're sharing. Most of it is file sharing. File sharing typically seen as something that you upload on like a torrent website, but no, anything that you upload as a quantifiable piece of data can be considered as file sharing. Now, in 2019, the total data storage capacity was around 50 zettabytes, right? Now, what we need to realize is that the jump from 1 gigabyte to another, like 1 GB to 2 GB is not that great. 1 petabyte to 2 petabyte is significant, but 1 zettabyte to 2 zettabyte is probably something which nobody has ever imagined or planned for, right? Because then you have 1000 to the power 7 more bytes to deal with. And today, in 2019, we had around 50 zettabytes of data. By 2025, it is estimated to grow to a range of 150 to 200 zettabytes, right? Let that sink in for a moment. 2006, we had only what? 160 exabytes of data. Now we have zettabytes, 200 zettabytes of data, right? That's just phenomenal, right? I mean, the amount of data, and this is growing every day, right? Facebook collects, I think, around 4.6 petabytes of data every day. So as consumers of Facebook, we are adding 4.6 petabytes of data just on that single forum. And that's not the only forum we use, right? We use a multitude of other forums. We have our trackers on our hands. Just imagine, just understand how much as a person you are contributing to these 200 zettabytes, right? And that is where the entire fun of being able to use this data, generate very personal insights and generate actionable insights that really impact the world comes from. As it's regularly said these days, data is the new oil, because the amount of information that we have about the world or the people who live in the world is ginormous, and that is the wealth of all. So now let's switch gears. Now that we know what scale we're talking about, let's switch gears and talk about Apache Software Foundation. We'll not take much time here. We'll briefly go through it. But the ASF was founded in 1999, March 1999, by a bunch of folks who were working on the first ASF project, which is the very popular Apache HTTP server. I think till a few years back, every website in the world was mostly hosted on the HTTP server. It's still a very active project. There are hundreds of open source softwares that operate under the ASF banner. If you have dealt with any software paradigm, you must have heard of something Apache Foo or some piece of software preceded by the term Apache. Wherever you see that, that's basically an ASF project. The advantage that commercials corporates see in ASF is that there's no vendor lock-in. So the product is open source. Anybody can use it, modify it. The ASF license does not mandate that you support the ASF in any way, or you give back your contributions, or you cannot take an ASF project, modify it, and offer it as a paid service. There are no restrictions of any sort of that form. And also it allows people to move across, right? So I'm using Apache Hive today. I've deployed an AWS cluster. Tomorrow I want to move out, I can just take that entire load and move to Azure or GCP or do my own hosting. Nothing changes, right? I mean, my application has no changes because I'm just dealing with Apache Hive, right? The product itself hasn't changed. It has just changed hands in terms of where it's deployed. So that is, how ASF got started. Now, quick brief of how the ASF model works. ASF is an organization. So they have top level projects, which are basically like independently run projects within the ASF banner. They have their own PMCs, which are called the project management committees. And project management committee has the VP who drives the entire project, and the PMCs vote and take decisions. There's a very clear meritocratic process of how decisions are taken. Sub projects are basically minor projects owned by top level projects. Incubator projects are a very special class of projects which are being currently incubated to potentially become top-level projects. Members are a group of people who have been nominated and elected, and they are the real shareholders of ASF, because ASF is a registered non-profit entity. It requires shareholders or stakeholders, and members are basically those people. And out of them, a board of elected representatives is elected every year, which consists of the president, vice president, treasurer, secretary, VP of public relations. There's a whole set. We'll not go into details, but ASF model is there for everybody to look at. And ASF is a very meritocratic and very open and transparent model. So that also adds to the charm for corporates to be attracted to it and start using it. ASF at a glance in 2020, by end of 2020, we were 227 million lines of code. Monetary valuation of ASF stands at $20 billion plus. We have 206 top-level projects, like communities, which oversee around 340 Apache projects at this point of time. Again, this was end of 2020. We publish an annual report, and 21 will be even more interesting. So in 2020, which were the most visited ASF projects, right? Now, ASF consists of 340 projects, and they are not all big data. They constitute of a huge spectrum of different technologies. So in the 20 report, what we saw was this. These were the most 5 active ASF projects, and they are Apache Spark, Apache Flink, Camel, Kafka, and Beam. And they have one thing in common, which is that they're all big data projects. So out of the 340 projects that we have, these were the most 5 visited, downloaded, and used projects. What that really means is that from an ASF perspective, right, our big data projects are also the ones which are getting the most attention. And that ties back to the fact that we have, the world has a lot of data, and much of that data is now being processed by ASF engines. And these are not the only ones, Lucene, Solar, there are multiple. So a brief history of Big Data Apache. Most of what we use today came from ASF. The seminal Apache Hadoop, Apache Yarn, HDFS, Hive, all of them started as ASF projects and are still ASF projects. The cutting edge, Spark, Flink, Kafka, Beam, Apache Pinot, recently built by LinkedIn. They're all in this space. They're all built by Apache. They're all maintained by Apache, and they are open source projects. So basically, all the big weights in the ASF, in the big data world, come under the Apache banner. Apache Hadoop, we'll briefly go through the big daddy of all. I'm sure most people have heard of Hadoop. Hadoop was started as a singular project based on the MapReduce paradigm given by Google. It was originally started by a gentleman called Duck Cutting. And then, from that, it evolved to a set of modules, which are collectively known as Apache Hadoop, but they do various different jobs. But they have a singular goal to support the processing of large-scale data. Again, and this was built on the MapReduce. Now it's ecosystem technologies, HDFS, Yarn, Hive, Pick, I think Scoop. Yeah, the whole family of projects. I think around 17 projects are now constituting the Apache Hadoop ecosystem. Spark is the king of the pack right now. It was started at UC Berkeley, and it's widely used for AI, ML, analytical processing. The founders of Spark, who were at UC Berkeley, started the famous company Databricks, which is, as of today, valued at around $38 billion US. Spark again. Why I'm focusing on Spark is because Spark is something that will be aware to a lot of our, will be known to a lot of our audience, but it is used by IBM Almaden. It is used by NASA JPL. It is used by multiple large research centers within active universities, such as Stanford Dawn, UC Santa Cruz, the Istanbul Sahi University. All of them are few examples of who uses Spark. We'll be going through deeper use cases, but just to give you insight of the taste of what Spark's use looks like. And now, one interesting thing that when I was preparing this talk, one of my colleagues actually asked me to focus on federal use cases, because typically the feds are very, they're very cautious about using new technology. So he asked me, hey, are there federal use cases which are actively solved by Apache projects or big data projects, right? And that got me thinking that, okay, if that is the case, and I knew of a couple of projects, that really tells two stories. One, there's a validation that these projects are really up to the mark and can, they are standards in terms of quality, so that feds trust them with such confidential data. And secondly, that is the best way of impacting the world, right? Because federal agencies or government agencies really allow you to impact the common man or the everyday man. So federal use case is something of great interest in terms of the user statistics of any Apache project. And I thought we can focus on that a bit. So a couple of again, for anonymity, I have not really included the specifics of which federal government agency is doing what, but these are across the world, right? I mean, they are collected from different governments, different cities around the world. So I just focused on the use case that is being solved by these technologies. So one very common use case that I think multiple federal agencies are solving is gauging public opinion. Given the fact that Hadoop can scrap and collect data over a period of time and also can correlate data, right? So using MapReduce, you can go across multiple data sources like Twitter and different forums, Discord, whatever, right? And you can then collect them and perform a sentiment analysis. That is an active use case solved by Hadoop today to generate an insight or a spectrum or paint a picture of what the public opinion is on a specific topic, right? And this is especially used by a certain agency when taking big decisions, right before taking a big decision, after taking a big decision, or maybe a new law, maybe a new tax, whatever, to to gather the impact of that decision. Hadoop is actively used. The other one is, this is a different use case, but this is also important. Predicting, critical networks from internal and external threats. There's a very famous paper by Lockheed Martin on this, where they actually specifically describe how they use Apache Hadoop in protecting their critical networks. And it's all intelligence driven. They predict what kind of attacks they can look at, they perform vulnerability analysis themselves. They also have an external and internal customer analysis, basically like people accessing their system from outside and inside and generating a threat matrix. So that paper really gives you a deep insight of how Hadoop is used at Lockheed Martin when operating with government agencies. And Hadoop provides them something known as information superiority, where they say that processing with Hadoop gives them the upper hand in terms of identifying what risk can be provided or being one step ahead of hackers. So this term is coined by Lockheed Martin, and that is what is generally accepted in terms of network security when intelligence-driven network security. This again is something that is done by I think two agencies. One was a very obvious use case. A standard ETL pipeline was being used where you pump data from multiple sources and you pump them to a MySQL database and then process some cleansing on it. But it took around 9 hours for the data volume. Using Hadoop and a MapReduce based model, they managed to cut it down to 60 minutes. So that was a significant cost saving for them. And because of the fact that they could get to the data faster, they were able to deploy more data models that required fresher data, and that allowed the insight base to grow. And the outcome was data processing was accelerated by a factor of 3, and searches, as said, the data search or the actual content search was expanded to include legacy systems as well, because now the data was faster and the access was cheaper, so you could go wide and even look at more data sources. This is an active use case by a Southeast Asian country where they're using Apache Spark to identify, it's a real-time analytical use case where they're identifying potential terrorist threats in terms of communication or patterns. For example, for this specific use case, they managed to identify a couple of profiles on a social media website who were brainwashing and targeting youth in terms of joining their organization or performing such activities. So it was a pretty complex analysis. They actually went ahead and did multiple sentiment analysis, message analysis, a lot of natural language processing as well. They also took data from other sources, not just that social media website. And it was a cross correlation model. And using all of these factors in Apache Spark, they were able to identify valid people with the criminal intent. And that was considered to be a huge success for the Apache Spark community, because it was a validation of all the machine learning capabilities that they've built over the years in the platform. Again, cost offset is something, it's not really relevant anymore, because we call, systems like S3 and Azure Block Storage are much, they have brought down the cost of storage, but some agencies still use HDFS as a block storage to reduce the cost from storing historical data on hard disks or SSDs. So that is one aspect that is still used, but that is not very active anymore. This is an interesting use case where Hadoop and Spark come in, join hands with different Apache technologies to really accelerate a very important use case, which is smart city management. So this is, again, a use case that I helped work on, because there were some questions around this from the relevant city government, and as an ASF community member, I also participated in this. But what they're really doing is they're using Apache IoTDB, which is the Internet of Things database. IoTDB allows you to stream data from multiple IoT devices, filter it, cleanse it, and build it into one repository. Apache Accumulo is a secure database, so it basically allows you row level access control. Spark is we've just talked about. So combination of streaming data through IoTDB, securing it through Accumulo, and then allowing Spark to perform ML jobs on it really allows the city to perform smart city management. And what they did realize was that they were able to validate consumer complaints. So if people are talking about a pothole in a certain road, they were able to generate insights using cameras or customer feedback and really trace the history. What really caused that pothole, what's the history there, which contractors were working on it. All of that really led to a sustained and actionable insight in the specific use case. And it also led to some interesting insights as to if this specific road is jam-packed, or if this specific area has too few roads, what can that lead to? Can that lead to more traffic in other areas, or can that lead to a housing problem? So the combination of these three technologies really allowed the city to gain a lot of insights into its current problems, as well as potential future problems that can generate from growing population or whatever other factors are. So that was a very interesting use case that the ASF actually saw. We actually mentioned an annual report as well. And smart city management is something that we see even adopted, it has a higher adoption rate than we expected. More and more people and more cities are coming forward and using ASF technologies to automate a lot of their city management. Again, self-driven robot, the US IRS actually uses robo auditors, again, built on top of Apache Hadoop to trace digital fingerprints. It's a menial task, but it's a long drawn task. So, MapReduce jobs are perfect for it. And that really frees up auditors, human auditors, to do better and more meaningful things. This is just wanted to give this project a quick shout out. So Apache Open Climate Workbench was actually a project started specifically for, monitoring and understanding climate patterns. And the interesting thing was that it is a myriad of multiple data sources that actually has remote sensing data from NASA, the Earth System Grid Federation, Coordinated Regional Climate Downscaling Experiment. A lot of federal agencies came together and helped accelerate this open workbench, and all of them benefited from it. So that, I think this project had a very resounding impact on how we looked at climate patterns and how we understood climate changes. And now this project has sort of gone into sunset because that data is now consumed by Hadoop and Spark and processed in a more ML-like way. But Open Climate Workbench stands as a good example of how multiple federations and how multiple federal agencies come together and fund and support an open source project that can have quantifiable impact on a burning issue such as climate change. We'll quickly walk through some of these ones again. These are some of the actual problems that we see. So back here in India, we are still an agriculture dominant economy to some extent. And these are some of the problems that are regularly seen by farmers in India. And what you see is that we have season quality, unpredictable rain, soil erosion, and farmers are not especially educated. So that adds to the problem. So what really happened was that this was an analysis done to see how technology can help a use case such as agriculture. So you have data-driven agriculture. If you can predict how the weather is going to behave, if you can measure the soil texture, the soil moisture, whether soil is conducive for a specific crop or not, all of that is really helping the farmer understand his own produce. And then at the end, when the produce is present, connecting to the right markets, not limiting to the local market, and ensuring that the farmer gets the right price for his crop. All of that is, again, data-driven insight that is going to be helpful for a country as large as India and even beyond, right? Other countries that are heavy on agriculture. So FarmOS is something that is open source web-based application, again built, and the underlying big data technologies remain the same. It's a comprehensive technology solution. It connects farmers, devs, and researchers. It also allows enforcing agriculture standards set by the country, and it is one-stop data management. So the good thing with FarmOS is that it allows you to collect data from different sources, from sensors put in fields, from measuring soil moisture and whatnot. Then the local weather station is able to broadcast weather statistics or weather forecasts, and FarmOS is able to give those insights to local farmers in a much more comprehensive way. And the one good thing here is that FarmOS has an interface which is developed to be very native and friendly. So it's in multiple languages. It is understood by, it is installed on devices given to farmers, and farmers are taught and they're given training as to how to understand the outputs of FarmOS and how to use it to their advantage. So FarmOS stands as a very good example of how data-driven agriculture can become a reality in a wide country such as India. The other problem that we also see locally is sanitation. Sanitation is still always gotten better, but sanitation still stands as a problem for India, where 65% of India's population in rural areas, 732 million people do not have access to toilets, and cost and one major problem you see is cost of building and maintaining toilets can be an impediment for multiple households that are below the poverty line. So again, this is something that is driven by Apache IoT, where you have reusable low-cost toilets driven by sensors and multiple IoT devices that really allow you to bring down the cost and automate a lot of the regular procedures or the maintenance of a toilet, and that brings down the cost and also reduces the load on the user or the group of users that are using it in terms of maintenance. So that is another example of how data-driven insights or data-driven technologies have helped accelerate such a ground-level use case. Again, this is Apache IoT, right? So another ASF project that has really percolated to the ground roots, which is, that is a ground level which is hard to imagine, right? So this is one use case I'm personally very proud of. Now we'll not go over this. These are some features. Again, one last use case that I want to talk about in this context, and these are in context of third world countries or growing countries. Again, some communities are very dependent on fisheries, and they require access to data which is specific to fishery resources, aquatic resources. The marketing network for fishing is especially weak. Then water pollution is a very growing problem. So all of these factors come into account when talking about the yield or output of a fishing exercise, and that directly impacts the economic situation of fishermen and their families. So these are two projects that are relevant here. Again, they are both, one is a data management project where it is an open Artfish database where there's open access to a lot of information that can help small scale fisheries. You have manuals, training course, material. It's like a small Wikipedia of different kind of fishes, different kind of water statistics, and that is regularly updated. That's a community-driven project. So that really allows small scale fisheries to understand what they're dealing with and how the scenario is changing, how the ecosystem is changing, and adapt accordingly. InSewe is an IoT-based sonar device, which is supposed to be low cost, and it really automates a lot of the process of identifying the right fish schools that the farmers can, they can then go and mine. So, that is again an IoT-based device that really helps improve the yield for farmers while reducing the amount of time. Sorry, not for farmers, for fishermen, while reducing the amount of time that they have to spend to get a certain amount of yield. So now switching gears a bit, this is another well-known DigitalGov and well-known use case of multiple Apache big data projects coming together and powering a very critical use case. So the DigitalGov project run by the United States government provides a hosted search service for multiple government affiliate organizations. If you go to usa.gov, the search engine is also run by the DigitalGov project. And the entire system is actually open source, right? They're very open about what they use. They use Apache Solr, which is a de facto Apache search engine. Lucene is a search library, which is extremely popular and which actually powers Apache Solr. Lucene for FI also powers multiple big corporate houses. OpenKalais and Apache Hadoop, right? So Apache Hadoop, again, the same process. You take feedback, sentiment analysis. We'll talk about what Apache Hadoop does here, but the DigitalGov project is completely powered by open source projects, specifically Apache projects, and it is very actively in use. We'll talk about where Hadoop, and again, Lucene Solr are very obvious because they power the actual search. When you put in a keyword, even you put in something of a text search, whatever query you have, that is being processed by Lucene and Solr. But Hadoop's role here is multifold, and we'll talk about that briefly. So, there are multiple phases to how Hadoop is used in DigitalGov. The first is search analytics. So search is a very complex use case, right? Before you actually fire a query, a lot of pre-processing is done to ensure that A, your results are very fast, and B, your results are relevant, right? So Apache Hadoop does that grunt work behind the scenes before a query is filed or a search is fired on DigitalGov. So all the search and API traffic that comes across hundreds of affiliate sites for DigitalGov, the iPhone app widgets, all of them come through a single search service, and Hadoop aggregates that data, that incoming data, in different buckets. There is an insight-driven model where we identify what are the main buckets or the main areas where users are searching for, and that is dynamic, right? You might be searching for something today, but a week later something else is hot, right? So based on a dynamic feedback loop, Hadoop aggregates that data into different buckets and then creates trends and basically pre-computes that search result for user to come in and search for. And as soon as you fire a search query, it is extremely fast because most of the work is already done for you. There's only a very small bucket that the query has to go through, and Lucene and Solr do the job pretty fast. And then there's a feedback. Once results are shown, then Hadoop captures clickstream analysis, which is basically what happened after the results were shown. Which of them were clicked on, how many times were they clicked on, did the user spend a lot of time on them, or did they close the page? That is in search terminology, we call it relevance and recall. And there's a feedback mechanism there. We try to understand what was the relevance of the results that were shown based on the user interaction. So that entire heavy lifting in this scenario is done by Apache Hadoop. Again, they've started with MySQL first, and then they solved performance problems, so they moved to Hadoop. Another example of how Hadoop has been transforming the big data ecosystem. We just talked about this. as a result, a typical stream of data, an incoming stream of data for DigitalGov actually took over an hour of processing, but then it went down 20 minutes using multiple containers of Apache Hadoop and MapReduce jobs. This is something we already talked about. Contextual results across multiple websites is something which is crucial for a system like DigitalGov, which is operating on multiple affiliate websites, right? It's not one search platform, they're operating across multiple search platforms. And they're also getting data from multiple search platforms. So it's N cross N problem. So contextual relevance is very crucial here. So, Hadoop, as I just described, helps categorize the incoming data into different streams and also maintain an active feedback loop as to how users have been interacting with search results. Combine these two factors, contextual results are specifically created for each website, and the relevant trends, which is what users are searching for, are pre-categorized so that when users come to search for the results, they're already there. The third one is internal monitoring. DigitalGov really depends on a lot of source results, and any problem on any of them, like a latency in one of the downstream sources, can cause a cascading effect across the system. So, Hadoop is also used for aggregating logs across all of the systems and then allowing people to do an analysis, or, for example, for allowing DevOps people to fire a query and see what was the average latency for a specific source, or which is the slowest source for the last 15 minutes. Without a system like Hadoop, it is very difficult to be going across multiple data sources, multiple logs, and performing a grep sort of analysis. With Hadoop and some jobs, like the Hadoop jobs, it is very easy to see all of that data in a structured form, aggregated over a period of time from multiple sources, and present in a SQL-like format, which mostly everybody understands. So in this case, they use Apache Hive, which is another Hadoop ecosystem project. They just took compressed logs from different engines into Hadoop file system, which is a block storage. A Surday is a job which processes those logs and creates a SQL table out of it. And then that table is pushed into Apache Hive. And Hive is a SQL engine, right? You can basically just query it and get results out. So this was a continuous process. Hadoop kept aggregating those logs, building that SQL table, performing regex, and giving the user a materialized view. So the review in Hive was continuously refreshed. So all the insights, all the metrics and internal logging and monitoring that was happening was all real time, so that any problem that is occurring in system can be detected as soon as possible. So I know this was a lot about different use cases that Hadoop ecosystem and all of the ASF big data projects are currently solving. One thing that is happening now is, as the scenario is changing, Hadoop ecosystem is actually getting shadowed. People are moving away from it. Real-time and analytical data is the new keyword. And the big thing here is cloud native. Now that we have a plethora of cloud providers in the world, a lot of big data projects or engines in Apache are actually building themselves to be cloud native first. So, for example, things like Kubernetes. Kubernetes really changed the overall way of deployment and access of these projects, right? So now engines are developing their core functionality to be ready to be deployed on something like an AWS or Azure, right? Or to be working with Kubernetes, be elastically scalable and downscalable just by using Kubernetes operators. So the rise of cloud technologies has really changed the landscape here, and big data engines or engine in general have, they have rethought their entire strategy. And now most of them are being cloud first. So now they do support on-premise deployments, but if you look at their most optimal use cases, they're at their best when deployed with a cloud native strategy in a cloud environment, like, I said, AWS, Azure, or what have you. And the other thing is, with the rise of IoT, a lot of incoming data is present, right? So you have like millions of endpoints that are continuously streaming data 24/7. There's no stoppage of data at any point of time. So you need high performance message queues, high performance columnar databases, streaming engines, all of that, a way to collect and make sense of so much of data. So as I said, IITDB, Pino, Pulsar, Flink, Beam, these are the most popular projects that are upcoming, and all of them are building themselves to be cloud native and ready for the massive Internet of Things revolution that we are currently seeing. So, as we progress ahead, we will see more of these technologies come forward, and they will actually be working hand in hand with the new advancements that large technological organizations are making. For example, some of these projects are working on accelerating them using FPGAs and GPUs, which is or they're working on accelerating themselves on the new M1 chip that Apple has come up with, or the I forgot the name, but the new chip that AWS just announced. So you will see more of synergy between open source projects and large corporations or hardware providers, and especially cloud providers. And that synergy will only grow as time progresses. So thank you. I hope this was not too extensive. I'm happy to take questions now.
Thank you very much, Mr. Sharma. Yes, we are sort of slightly over our time, but we still have more. I mean, let's have a Q&A session, because this was a very, very interesting presentation, and I'm sure there's going to be questions from the audience. Just to remind the audience, please post your questions in the Q&A tab that you see at the bottom of your screen. Going back to your presentation, Mr. Sharma, I just wanted to ask, as we look towards the smarter future, and the need for big data analytics only gets bigger and bigger, and the use cases and development problems to solve get more varied and complex, and go across different sectors. For industry counterparts and sustainable development practitioners, what would, in your view, be the appropriate criteria to consider as you build a case for investing their scarce resources in modern open source big data technologies?
Sure. I think, as I said, data is the new oil, and there is no industry in the world which is untouched by this data revolution. So many a times what happens is that a lack of revenue or a loss in business is really caused by the fact that, the company or the specific industry did not take into account the fact that their data needs to be managed in the right way. For example, there was a use case where a company decided to use Apache Kafka, and they did not know how they were going to use it in the right way, and they ended up paying a lot of money when they did not need to, just on infrastructure cost, right? So for any industry, they need to, for every industry, they need to be cognizant of the fact that in some form they will have data, and the management of that data as it grows is vital for their success and as well as for their cost management. So, you should be a part of the overall data management solutions, and you should be investing into that specific area, even if it is not in line of a business, because at the end of the day, your data management platform is going to be one of your key fundamental technologies upon which your application logic resides. I think.
Yeah, sorry, I was muted. I was talking about muted. Apologies. Seems to happen all the time. But I just want to also ask, from the perspective of the Apache Software Foundation, is there ongoing demand for newer technologies building on the likes of Hadoop and Spark? And are private sector companies and industries more supportive of open source initiatives?
Absolutely. In fact, now that you mention it, I think in the recent times, what we've really seen is that most of the new innovative projects that have come out from large corporate houses. I think the mindset has shifted. Just from being plain consumers of open source technology, companies are now looking to build in-house tech that solves their use cases, and then donate it back to open source. A good example of that is Apache Pinot, which is a very fast columnar database, recently donated by LinkedIn, and it has been in production LinkedIn for many years now. And Pinot has really taken like 40 to fire because it's extremely fast, and now it's being used by multiple other projects, and it's one of the fast rising projects in Apache, right? And similarly, we have multiple other use cases. We have Alibaba, Tencent, Huawei building and contributing actively to major open source projects, sometimes even being the biggest contributor or driver of those projects. So I think the paradigm has shifted. Corporate houses want a larger degree of say and contribution in terms of how big open source data projects are being driven.
Thank you very much. And I have a question from the audience, which is asking us whether you would be able to share the case studies that were done on agriculture and fisheries. Is that something that is possible to share?
So I have like white papers on that. I can share them offline because there's a lot of information there. So
sure. Okay, then we will look for a way to get that to our participants. I'm not seeing any other questions from the audience coming in, and we are sort of 15 minutes overboard. So I would like to thank you, Mr. Sharma, for your very thorough presentation and for your time. I know it is very late in the evening already in India, so thank you very much for joining us from so far away. We are really, really privileged and pleased to have had a chance to virtually welcome you to Trinidad and Tobago and to the United Nations here in the wider Caribbean, and for our big data forum. I think this has been a very, very interesting and in-depth analysis with really unparalleled knowledge. Unfortunately, I couldn't understand half of it. So I'm not very, very, very proficient in this field, but I see that our participants have enjoyed it and have greatly benefited from it. So thank you one more time for your time. I would like to invite all the participants to come in for our next session. What do you call it? Session 4 of day 2, which starts in just over 20 minutes. And which looks at the use of artificial intelligence for social good, with IDB and UNDP participating. So thank you once again, Mr. Sharma. Thank you all for participating, and have a lovely rest of the day. Thank you.
Thank you. Thank you for having me.